Hi everyone. Today we are going to discuss about osmosis. So we have in the previous class discussed about the diffusion process, facilitated diffusion process and imbibition process. And in these sessions we are going to discuss about osmosis process. What is osmosis process? What is an osmosis process? So this osmosis process is just like a diffusion only. It is a special type of diffusion. Osmosis is a special type of diffusion. Why do we call it a special type of diffusion? In case of diffusion and facilitated diffusion, we might have studied that all the substances, non-polar and polar substances, are entering into the cell membrane. So, non-polar and smaller in size, this kind of substances quickly diffuse into the cell membrane, whereas the polar substances, which are larger in size, they need some protein cell, that is an facilitated protein. With the help of the facilitated protein, these polar substances bind and penetrate into the cell membrane. Okay, so all the substances are entering into the cell membrane, and especially though they enter into the cell membrane, they can't come out easily. They can't come out easily. So only they can enter into the cell membrane, but the exit of the substances from the cell membrane is difficult. But whereas in case of osmosis and this water molecule, osmos, then water molecule. Osmos means urge. Okay, so this osmosis, in case of osmosis, water molecules enter into the cell and exit outside of the cell. Both the process is done by this water molecule. That's why this type of osmosis is a special type of diffusion where the water molecules or solvent molecule can enter into the cell and can exit outside of the cell. Dual process, they can go bidirectionals, can enter inside, can exit. Other molecules, only they can enter inside, they can't exit quickly. But these water molecules, they are able to enter inside the cell and exit outside of the cell also. But this entry and exit, the quantity of water differs. The quantity of water differs to the entry as well as to the exit. So large amount of the water molecule can enter into the cell membrane, but the less amount of the water molecule can exit outside of the cell membrane. That is the special point lying in this concept. Okay, so it's a special type of diffusion. So how it is defined? How this osmosis is defined? எப்படி define பண்ணலாம் the osmosis already we studied the definition of diffusion. அங்க என்ன சொல்றேன், definition of diffusion, the movement of the substances from higher concentration to lower concentration, okay, across the membrane. That's we call it in a diffusion, the movement of substances from its higher concentration to lower concentrations across the membrane. Am I right? Here also same thing you are going to say, but with a technical term. So this water molecules or solvent molecules move across the membrane from its higher concentration to lower concentration. From its higher concentration to lower concentration. From its higher concentration to lower what is the meaning of higher concentration here? How we can able to say water molecules is having that higher concentrations? Okay, there is a term used to explain this water potential. To simplify that osmosis definition, the term is used water potential. Let me write the definitions. Okay, water are solvent molecules move from its higher concentration to lower concentration through membrane, plasma membrane, through plasma membrane. The definition. So water or solvent molecules move from its higher concentration to lower concentration through the plasma membrane. This is the definition of osmosis. Here we have to study about what is higher concentration, lower concentrations in terms of osmosis. So higher concentrations, so higher concentration is high water potential. High water potential. High water potential. So the movement of the molecules, solvents or water molecules from high water potential to low water potentials. Okay, so that's the definition. Now we should know what is water potential. Water potential and what is the water potential? Without knowing this concept, we can't further continue into the topic. So thereby we must know what is water potential. Okay, so water potential is defined like this: potential energy of water molecules. Like that, potential energy of water molecules compared to the pure water. Potential energy of water molecules compared to the pure water in a system where the temperature and atmospheric pressures are same. Okay, that's we call it an water potential. Okay, so what is water potential? Water potential is defined like that: potential energy of water molecule compared to the pure water in a system with a constant temperature and atmospheric pressure. Okay, so these water molecules have the kinetic energy, can freely move. Okay, the free energies are available, due to that it move freely, so flow. The water molecules are able to flow easily. Okay, got it? So these water molecules, the water potential of pure water, you should keep it in your mind. The water potential of pure water is 0. The water potential of pure water is 0. How do we denote this water potential in the symbol? Okay, so this water potential is denoted in a Greek word psi. Okay, the water potential is denoted in the Greek word What is that? Psi. The symbol will be okay. It is also measured, denoted as Pascal. Pascal, they write it like this, PA. Okay. So the water potential is denoted from the Greek word that is psi. Okay. The symbol is psi. And it is measured. It is known as an Pascal. Clear? This is a water potential symbol. So, as I told, the water potential of pure water is always zero at a constant temperature and pressure. The water potential for pure water is always zero at the constant temperature and pressure. So when it can be changed? When it can be changed? So this water potential can be changed, reduced or increased based on the solute molecules what we add. When the solute molecule is added to the pure water, the addition of pure solute molecules to the pure water may decrease the kinetic energy of pure water. Decrease the kinetic energy of pure water and it decreases the water potential. Okay. So when the kinetic energy, as the kinetic energy of water potential, pure water decreases, then the water potential of pure water will be decreased. Okay. So thereby this water potential, in a solution the water potential is very low than the pure water. In a solution, in a given solution, the water potential will be low than the pure water in a system. Okay. So always the solutions solution has low water potential. Low water potential. Okay. Always the solution has low water potential. Clear? And pure water only having high water potential. Apart from that, when we add a solute to the pure water, then the dissociation of the solute will decrease the kinetic energy of the pure water and lead it to the decrease in the water potentials. Okay. So thereby it is denoted. In the solution, the water potential is denoted as a negative expressions. So in a negative value. The water potential in the solution will be having the negative value. So it is expressed in negative value because we are adding solutes to the pure water, so thereby the kinetic energy decreases, thereby the potential energy, water potential energy decreases, and it goes in the negative value. Got it? Clear? That's good. And let's move to some more. This water potential is determined by two main components. Water potential is determined by two main components. What are the two main components? So one is an solute potential, another one is an pressure potential. One is an solute potential, another one is an pressure potential. So what is solute potential? When the when we add a solute, so this is a consider pure water. This is pure water. We are adding the solute. So when we add the solute, what happens? Automatically decrease kinetic energy. Kinetic energy decreases and decrease water potential. Kinetic energy decreases and decrease water potential. Okay. In case of solute potential, I will give you that illustrated diagram. Solute potential. See, this is a pure water. This is pure water. Okay, at a constant temperature and atmospheric pressure, at normal temperature and atmospheric pressure. Okay, we are adding the solute. This is solute to the pure water. Now we added solute to the pure water. As much as you are adding the solute to the pure water, and kinetic energy also decreases. So thereby what happens? Decrease kinetic energy. So when kinetic energy decreases, what happens? Next thing, so kinetic energy decreases means water potential decreases. Do you understand? I hope so. This will give you a clear idea about the solute potential. Okay, what will happen now? When we add the solute molecules to the pure water, the dissociation of solute molecules in the pure waters, okay, lead to decrease the kinetic energy of it.